Hello friends, welcome to Engineering Funda family. In this video, I will discuss about phase shift keying with great clarity. Before I start with my explanation, let me tell you the outlines of this video. In this video, first of all, I will discuss about basics of PSK. After that, I will explain waveforms, bandwidth and multi-level PSK. After that, I will explain demodulation process of PSK. After that, I will discuss about constellation diagram of PSK, and at last I will explain advantages, disadvantages and applications of PSK. So let us start this video with first agenda, that is basics of PSK. See, PSK is phase shift keying, that is digital modulation scheme by which we will be converting digital signals into analog signals. So here our input will be digital signals and that we will be converting into analog form by varying carrier's phase. So here by changing phase of carrier, we will be converting digital signal into analog form. So in PSK, we will change phase of carrier according to digital message signal. Let me take one example of binary PSK. See, in binary PSK, we are considering binary message signal empty. With binary message signal, we have logic 0 and logic 1. Here, our binary message signal, that is +1 in case of logic 0 and that is -1 in case of logic 1. So what will be our binary PSK signal? Binary PSK signal will be A cos omega ct, that is carrier for logic 0, and it will be minus A cos omega ct for logic 1. See here, if you talk about carrier, then carrier is A cos omega ct. And for logic 0, phase will be 0, and for logic 1, phase will be 180 degree. If you have cos of omega ct plus 180 degree, in that case, that will be minus A cos omega ct, right? So this is standard example of binary PSK, where what we are doing? We are changing phase of carrier with respect to digital signal. For logic 0, phase is 0 with carrier, and for logic 1, phase is 180 degree for carrier. Due to 180 degree phase over here, we have negative sign, right? Now let me explain how to have a modulation of binary PSK. So here you can observe we have binary data. Binary data will be 0 and 1, right? So first of all, that binary data that we will be converting with the use of bipolar NRZ encoder. See, in bipolar NRZ encoder, we will be having +1 and -1. You can consider +1 for logic 1 and you can consider -1 for logic 0, right? And that bipolar NRZ data, which is plus or -1, that we multiply with carrier and that is generating binary PSK. So you can observe, if you multiply plus or -1 with carrier, then that is resulting into binary PSK signal. Now let me explain that with respect to waveforms. So here we have a digital data, you can observe. See, this digital data that can be +A or -A. Here with +A we have logic 1 and with -A we have logic 0. Here we have considered bit duration to be TB, you can observe. So with each bit duration is TB, right? Now here we have a carrier signal, you can observe, that is cos omega ct. So now in binary PSK, what we do? We multiply carrier with digital data, right? So you can observe after multiplication, we have binary PSK signal where as if we have logic 1, at that time signal is A cos omega ct, you can observe. And as if we have logic 0, then over here there is a phase reversal. And that phase reversal is of 180 degree. So you can observe here we have minus a cos omega ct. So we have signal that is minus a cos omega ct during logic 0, and during logic 1 we have BPSK signal that is a cos omega ct, right? So that is how one can understand waveforms of PSK. Now let me discuss about bandwidth of PSK. See, binary PSK signal or any other form of PSK, like there can be QPSK, there can be 8PSK. So here with QPSK, we will be having 4 symbols. With each symbol, there will be different phase. Like with binary PSK, we have phase of 0 and 180 degree. Likewise, with QPSK, one can have phase of 0, 90, 270 and 180, right? And here you can change the phase even like 45, 135, 225 and 315. That is up to you. With 8PSK, there will be phase with 8 different levels. So phase will be 0, 45, 90, 135, 180, 225, then 270 and then 315. So here there is a change in phase, right? But if you observe the bandwidth, then that will be as per from Fc minus Fb to Fc plus Fb. So how much bandwidth is there? Here bandwidth is 2b only, right? So that is the minimum bandwidth. Irrespective of we have BPSK, QPSK or 8PSK, right? So with phase shifting, bandwidth will be 2FB, where FB that is there as per Nyquist rate, that is R by 2, right? And if you want to understand bandwidth with respect to baud rate, then that will be 1 plus alpha into R. Here R is baud rate and alpha is roll of factor depending on filtering. Ideally, one can say bandwidth is baud rate of signal, but we don't have ideal filters, right? For ideal filters, there will be sharp edges with filter, but practically you will be observing there will be somewhat slope, due to which you will have to have bit higher bandwidth. So that slope is defined by this alpha, right? So based on roll of factor of filters and baud rate, one can understand bandwidth, and minimum bandwidth that is 2 times of FB, right? And FB is how much? FB is 1 divided by TB, where TB is bit duration, right? Now let me explain multi-level PSK. To understand multi-level PSK, let me consider BPSK first. See, for binary phase shifting, there will be 2 symbols, right? So when you talk about BPSK, at that time levels are 2. That is 2 to the power 1. What it means? Here, with each symbol, there will be 1 bit. And if you talk about 2 symbols, then with each symbol, there will be phase as per 0 and 180 degree. See, level 1 that is having 0 phase and level 2 that is having 180 degree phase. If you talk about digital data, then with logic 0, we will be having 0 phase, and with logic 1, we will be having phase of 180 degree, right? Now, let me take second example. Here, now I'll consider QPSK. One should know QPSK, that is also referred as 4PSK. What it means? It means here we have in total 4 levels, that is 2 to the power 2, means with each level we have 2 bits, right? In total 4 levels are there. So with each symbol, phase will be as per 0 degree, 90 degree, 180 degree and 270 degree. If you talk about digital data, then that will be 004 phase 0, 014 phase 90 degree, 104 phase of 180 degree and 114 phase of 270 degree, right? So that is how one can understand digital data Let me take one more case of multi-level PSK. Now I'll take a case of 8 PSK. See, when it comes to 8 PSK, then but obviously how many levels are there? In total 8 levels are there. That is 2 to the power 3. Means with each symbol there will be 3 bits. If you talk about phase, then in total 8 levels are there. So 0 degree, that is level 1. Then see 360 divided by 8, that is 45. So second symbol is having phase of 45, then 90, then 135, then 180, then we have phase of 225, then 270, then 315, right? If you talk about digital data, then with 0 degree phase, one can have symbol with digital data 000. Then with 45 we have 001. With 90 we have 010. With 135 we have 011. With 180 we have 100. With 225 we have 101. With 270 we have 110. And with 315 we have 111 digital data, right? So that is how one can understand multi-level PSK, right? So in PSK, phase of carrier changes as per digital data. With multi-level, you can observe with individual phase, we have multiple bits, and that we need to understand as per total number of levels, right? Now let me explain demodulation of PSK. Here I'll take a case of binary PSK. So you can observe here we have BPSK signal. What is BPSK signal? That is MT into cos of omega CT. One should know this MT, that is plus or minus 1, plus 1, that is associated with logic 1, and this minus 1, that is associated with logic 0, right? So this is BPSK signal. That is what we are multiplying with carrier signal. What is carrier signal? It is simply cos of omega CT. So when you multiply these two signal, what will be resultant over here? That will be simply MT into cos square omega CT, right? And that is what we pass it through low pass filter and will be having message signal. Let me explain how. See, output of low pass filter that we want, right? But output of multiplier, that you need to understand. See, output of multiplier, that is MT cos square omega CT. What is cos square? Cos square is 1 plus cos 2 omega CT divided by 2. So here we have MT by 2 and we have MT by 2 into cos of 2 omega CT, right? So when you pass this signal through low pass filter, what will happen? It will eliminate this high frequency component and it will only allow message signal. So here you will be having MT by 2 signal, and when you give this MT by 2 signal to comparator, we will be having digital data. What is MT by 2? It is plus or minus half. So if you have plus half, at the time we will be having logic 1. If you have minus half, at the time we will be having logic 0 over here. So we will be having 0101 digital data available over here, right? So that is how one can do demodulation. Now let me explain constellation diagram of PSK. First of all, let me explain what is constellation diagram. See, in constellation diagram, here we have two axes. Horizontal axis is I and vertical axis is Q. In constellation diagram, we will plot symbols. Let me take one example. Here I'll take example of binary PSK. See, in constellation diagram, with respect to center, distance is amplitude, and with respect to horizontal axis, angle is phase. So here we will be having two symbols with binary PSK. See, here we have symbol for logic 0 that is having some magnitude over here, and that is having phase of 180 degree. And here we have symbol for logic 1 that is having 0 phase over here, right? And in binary PSK, it is not compulsory, like symbol should be having phase 0 with logic 1. You can take logic 1 over here and logic 0 over here. That is up to encoder, right? Now, let me take one more example of 8 PSK. See, in 8 PSK, we will be having 8 different symbols. Here, I have drawn one circle, right? Means with each symbol, amplitude will be constant, right? But with each symbol, there will be different phase. Here, in total, 8 symbols are there. You can observe. This is first symbol, second symbol, third symbol. Likewise, we have in total 8 symbols. Here, with this symbol, we have phase 0. With this symbol, we have phase 45 degree. With this symbol, we have phase of 90 degree. With this symbol, we have phase of 135 degree. Likewise, we have different symbols, right? And with 8 PSK, with each symbol, how many bits are there? 8 is equals to 2 to the power 3. Means we have 3 bits. So with this given symbol, which is having phase 0, we have digital value that is 0, 0, 0. Over here with this symbol, we have phase 45 degree that is having digital value 0, 0, 1. Likewise, with different symbols along with different phase, one can have digital values, right? So this is how one can understand constellation diagram. Always remember, in phase shifting, you will be observing with every symbol, distance with respect to center, that will be fixed, right? And symbol with digital data, that is there as per phase. Like in binary PSK, we have phase 0 over here and phase 180 degree over here for logic 0 and logic 1 respectively. And for 8 PSK, we have 8 symbols. So with these symbols, we have phase as per the separation of 45 degree. See, in total 8 symbols are there. So 360 degree, that is bisected into 8 symbols. So 360 divided by 8, that is 45. So with the spacing of 45 degrees phase, we have a symbols over here, right? Now let me explain advantages of PSK. See, first major advantage, that is based on power efficiency. Here you will be observing with PSK, we will be having constant frequency. Digital data depends on phase, right? And here amplitude is constant. So you will be having better power efficiency over here. See, second advantage is based on bandwidth. We have better bandwidth. Why? The reason is, here you need only 2 times of FB amount of bandwidth. That is minimum one, right? So we have better bandwidth efficiency over here. Compared to frequency shifting, we have far better bandwidth with PSK. When it comes to envelope, then we will be having constant envelope. Why? The reason is, PSK signal that is having constant amplitude. So, but obviously envelope of signal will be constant even, right? When it comes to disadvantages, then first disadvantage is based on phase synchronization. And one should know phase synchronization, that is quite complicated, and cost of the circuit, that is way high for phase synchronization. So that is highly required over here. Second disadvantage, that is related phase noise. It is very sensitive to phase noise and Doppler. One should know what is Doppler. See, as if signal is traveling in space, and if we have a receiver over here, and as if receiver is in motion, then what will happen? Then there will be Doppler effect with received signal. Now, what is Doppler effect with received signal? See, Doppler effect means here there will be change in frequency with received signal due to motion of receiver. So as if there is a phase noise or a Doppler, then PSK signals that is very sensitive, right? See this PSK that is having higher noise with multipath fading. As and when we receive signal from multiple path, at that time it is having higher noise. The reason is here we need to extract phase, that is information, right? Now let me discuss about applications. See, we can use that in Wi-Fi. Nowadays we are using that along with Wi-Fi with BPSK and QPSK. It is also used in cellular network with LTE and 5G. We have QPSK. It is also used in satellite communication. With DVB-S2, we use 8PSK. It is also used in short range and IoT applications. So that is how with phase shift keying, there are many advantages and many applications. Overall, one can say PSK is band efficient digital modulation scheme. That's why it is widely used in many applications. Still, if you have any confusion, just place that in comment section. I'll be happy to help you. Thank you so much for watching this video.